So this is more of a theory lecture around partitioners and how keys are hashed. This is definitely something that is more advanced, and some students are just curious, so maybe you're curious too. So here is how keys are hashed. Basically, your keys, using a serializer, they're converted into bytes, series of zeros and ones. Now, your keys, these bytes, are going to get hashed. And hashed is basically a big mathematical formula to basically transform all these numbers into a final value. And Kafka uses the murmur2 algorithms. And so this one is a really good one for distribution of hashes. You don't need to know more than this, it's enough. Now, basically, it's most likely preferred never to override the default partitioner, but it is possible to do so. So if you wanted to provide your own partitioner class and get more control over how it works, you could have a setting in the producer called partitioner class. Overall, I never recommend people to override this class unless they know exactly what they're doing. Now, for the default partitioner, here is the target formula. That's straight from the Kafka code. And it says target partition equals the absolute value of the murmur2, okay, of the record key, hashed modulo the number of partitions. So basically the record key is going to be hashed to a number, we'll get the absolute value, and then we'll have a modulo. And so this is all for you to know about. It's just for your curiosity. But basically from this formula, we see that the same key, okay, the same key will go to the same partition, because if you have twice the same record key, then this formula will be exactly the same. And we see that if we add partitions to a topic, well, it will completely alter the formula because num partitions on the right-hand side will basically change. And so this is why when you create a topic and you set it to having maybe 6 partitions, you cannot increase the number of partitions in the future unless you're willing to lose this hashing formula. Such as the same key will go to the same partition. Okay, so I hope that helps. Again, just theory section, lecture, nothing for you to do on this, just for those who are curious. And I will see you in the next lecture for another quite advanced setting, again, just for your curiosity. So these two settings are called max block millisecond and buffer memory, and they are super advanced in my opinion. And this is only when you run into these exceptions that you really need to look into those. So as a beginner level, don't even look at these things unless you get the exception we're going to visit right now. So basically, the exception happens when the producer produces way faster than the broker can take. And so basically, the broker cannot ingest data fast enough. Maybe they're overloaded, or maybe you haven't sized the broker correctly, or maybe there's a peak of usage of your applications because, I don't know, you got viral. So basically, the producers, because they produce faster than the broker can take, the records are going to be buffered in the producer memory. And by default, each producer has a buffer memory of 32 megabytes. That's basically the size of the send buffer. That buffer will fill up over time, and then will fill back down when the producer is able to send data to the broker in a faster way, okay? Now, if the buffer is full all the way, so all 32 megabytes of your buffer are complete, so that means that the broker has been down for quite a while, or that your producers are producing really fast, then the dot send method will start to block. It won't return right away. And basically that means that your code won't try to produce more data, it will just wait. And this wait is controlled by max block milliseconds, which is set to 60,000 milliseconds, so it's 60 seconds, 1 minute. And that's the time the dot send method will block until throwing an exception. And this is the exception sometimes people see when they have super high throughputs. So if you see it, then you're aware of these settings. These exceptions are thrown when, for a couple reasons. Number one, the producer has basically filled up his entire buffer, or the broker is not accepting any data, or 60 seconds has elapsed. And so if you hit that exception, that basically means that your brokers are down or overloaded and they can't respond to requests, and your producers will go down as well for a while until the brokers are recovered. So this is something quite obscure as a beginner, but trust me, if you go full into Kafka and you get this exception, you'll be happy for this lecture to be here. So I hope that helps. And that's all for a producer in the real world type of setting with all these insane configurations to make it safer and high throughputs. And I will see you in the next section.